Hello everyone, welcome to my presentation. I am Furkan Perçin, 4th grade Electrical and Electronics Engineering student in İzmir Çelebi University. The name of my project is Low-Cost MATLAB Simulink Compatible Data Acquisition Card Hardware and Software Designed for Control and Test Applications. Also, I would like to introduce my supervisors, Associated Professor Savaş Şahin from İzmir Çelebi University and Alkın Gökçen from Baylan Smart Water Meters and Energy Meters. Let's look at the outline of the presentation. First, we will see introduction, then motivation, methods, results and discussion, and finally conclusion section. Let's start with introduction. Data acquisition is the process of sensing and measuring the physical or electrical phenomenon and converting the data into a digital form to accomplish meaningful information by computer programs. In general, a DAQ system is a combination of software, hardware, and a computer program to process acquired data. The aim of this project is to design a data acquisition card with ARM Cortex-M4 processor and to ensure that this card is MATLAB Simulink compatible to control and process its interaction with the environment. The microprocessor performs data acquisition, functional filtering, and communication tasks. The library was created in the MATLAB Simulink environment for the control of this data acquisition card. In the system, the data acquired by the microprocessor is transferred to the computer via USB serial communication method. Now, I will try to convey the motivation of the project to you. Different companies have a large number of data acquisition systems in different models. The purchase of these existing devices or the solution of any problems that occur in these devices are huge costs to individual users. They cannot afford and require large budget allocations for companies. Therefore, there is a need to provide a low-cost data acquisition system suitable. It is aimed to achieve high performance by providing flexibility with libraries created for the low-cost hardware part of the system. Purpose of the system: low cost, getting accurate results with high resolution, increasing performance for the project in the laboratory environment, usage with the desired solver in the MATLAB Simulink environment, facilitating the data exchange process by creating our own libraries in the MATLAB Simulink environment, by using the systems used by the company as error and fault detection systems. It is aimed to accelerate the solution of the fault and error and to prevent large expenses for the company. The methods, research, and development stages to be applied in the hardware design, software design, and testing process to be carried out within the scope of the proposed system. This part of the method section will consist of designing the electrical circuit diagram that includes the connections of the microprocessor and the input-output ports and peripherals, and then transferring this diagram to the printed circuit board. The system has 4 digital inputs-outputs, 2 analog inputs, 2 analog outputs, 4 PWM outputs, and L298 driver and encoder inputs. In the left of the slide, you can see the top layer of the PCB. On the other side, there is a bottom layer of the PCB. In the Altium Designer program, microprocessor and peripherals were created according to the determined pins. Here is a picture of realized data acquisition card from different angles. Communication between the computer and the card is provided by USB connection. With TTL communication over USB, data obtained through sensors and other peripherals will be received, and easy data transfer to the computer will be provided with the blocks prepared in the MATLAB Simulink program. Data packets called telegrams are created to transfer data securely. Thus, the communication between Simulink and the hardware is provided without any problems. 9600 bps is used as the communication rate. In the software phase, first, the embedded software required for the microprocessor to acquiring data, functional filtering, and communication tasks was designed. Secondly, a library was created in the MATLAB Simulink environment in the work by communicating the DAQ card through the serial communication interface for the control of the card, and the sample of the data is provided. The Simulink library monitors and controls the DAQ card, and you can see the blocks of the library in the figure 7. Let's examine the one specific block among the other blocks in the library. The PWM output block is designed to modify the PWM signal with 4 channels. In the block parameters tab, we can choose one of these 4 channels. and we can determine the frequency of that channel signal. The input of this block is a duty cycle PWM output. For the results and discussion section, different scenarios were applied to test the design, DAQ cards, functionality, and the Simulink library's operability. One of these scenarios tests the ADC input and PWM output with the related blocks in the MATLAB Simulink. The rotation speed of the DC motor connected to the L298 driver on the board is adjusted with PWM according to the temperature value evaluated from the ADC. In the left, there is a 10 kHz PWM signal with a 25 duty cycles, and in the right, LM35 temperature sensor plot. In the conclusion, ADC, DAC, encoder, PWM, digital IOS, and L298 driver are integrated into the system to meet requirements best. Due to the blocks in the library created in the MATLAB Simulink environment, data from the relevant peripherals can be interpreted and sampled, and actuators can be controlled. The purchase of existing DAQ systems or the solution of any problem in these devices are enormous costs that individual users cannot afford and require large budget allocations for companies. Hence, there is provided a low-cost, compact size, low power consumption, and high-resolution device with a software library suitable for control and test operation. For future works, machine learning algorithms can be applied by creating a dataset from the obtained data. Thank you for listening to me. If you have any questions, I'll be glad to answer them.